All right then, we'll kick it off. Hey everyone, nice to see friendly faces. We're going to do a presentation, a panel on data locality, cracking the data locality puzzle, it says. Not necessarily because we up here have cracked this puzzle, but because we hope to one day crack the puzzle. We're going to take you through some of the difficulties as we see it in the cloud-native universe, and some of the things that are being done in this in the ecosystem to try and address data locality and the problems that we see. I've got 4 lovely panelists up here with us, one of whom is a recent recruit, another who's a slightly less recent, but almost as recent recruit because of all of the FAA regulations, or shutdown things. So very happy to field a full panel today. Very quickly, we'll go around the room. Abhi, you want to kick off?
Yeah, sure. Hi, this is Abhishek. I primarily work on distributed computing and resource management. Currently, I'm building an open source platform that runs AI inference workloads. I spend most of my time getting more performance out of GPUs so that your AI models can run cheaper while respecting SLOs. Happy to be here and looking forward for the discussion.
Okay, I'm next, I guess. Hello, everyone. I'm Ekin from NVIDIA, specifically from Run.ai team. I'm mostly working on scheduling AI workloads on huge clusters with Kai Scheduler team, which is our open source scheduler. And also, right now, I'm focusing on optimizing model inference workloads on Kubernetes as well. Very happy to be here.
Yeah, good afternoon. I'm Wilfried Spiegelenburg. I work for Cloudera. I am one of the primary people on Apache Unicorn, Kubernetes scheduler, and I'm looking at scheduling from a basic perspective, like batch jobs, workloads, everything like that.
I'm Dan Desjardins from Distributive, and my background's in physics modeling, and so I'm very interested from an academic perspective in looking at how you make all the pieces fly around and land in the right place in the right time to get maximum throughput. So very much to distribute or not to distribute.
Lovely. And I'm from G Research. My name's Alex Scammon. I lead the open source program office for G Research, which is a band of merry open source people who get to contribute to all sorts of interesting projects around the technosphere, one of which is a Kubernetes batch scheduler, which is why we're so involved or interested in this particular subject. With Abhi, I run the batch working group for the CNCF. And data locality comes up all the time. It is a very complicated problem. Whenever we start to scratch the surface, we get tired and frustrated and then want to talk about something else because it's hard. But so we're going to try and talk about it because it's, well, no, it's a solved problem, I think. It's super easy. Just to go around the room, the reason that we put this panel together is that there's a breadth of viewpoints here, and I'd just like to just get at that a little bit. When we talk about data locality, it could mean a bunch of different things to different people. So, well, I'll start down with you, Dan. Like, for you, when you think about data locality, you're coming from a very different point of view than everyone else. I should introduce Distributive is Dan's company, and it is not a Kubernetes-based company. And it's one of the reasons I wanted to invite him here, to get a different perspective on it. Yet, you're doing HPC jobs, distributing that around the universe. When you think of data locality, what does it mean to you?
On that note, we're doing the thing you're not supposed to do, which is reinvent a scheduler, but we'll either make all the same mistakes again or we'll stumble on something different. And we're experimenting now in academic settings. So we're giving this technology to schools, and one of them is Africa Nazarene University in Kenya. And we have one scheduler, and it's physically located in North America. So it makes no sense right now for data to go back and forth round trip from Kenya to Kenya through Canada in order to compute across a couple of machines. And so it makes it really painfully obvious that moving data is expensive, and you have to figure out how to do it or not do it. And so locality is critical because it makes a product unusable, basically, if you don't take it into account. And so that's what we're interested in.
Perfect. And Wilfred, just sort of from a similar standpoint, looking at the macro, yes?
Yeah, so I'm from a Hadoop background, so HDFS, Yarn, all that kind of stuff. We've had data locality there. HDFS, it's got Rex, it's got Node. The scheduler knows exactly where the data is, so it puts the job as close to the data as it can to get as high performance as you can. On Kubernetes, we don't have that. Jobs get scheduled on a node. Data could be anywhere. So from that perspective, it's a high level. Get the workload as close to the data as you can, but it's not there.
Yeah.
Yep.
Totally. And Ekin, you're sort of coming at it from a slightly different point of view. When I say data locality to you, what does it mean?
Yes, so a small disclaimer, I'm a machine learning engineer actually as a background. So for me, data locality means me turning on basically an application. Let's say it's an AI inference workload. I want my model data, let's say model weights, to be on the GPU working as fast as possible. I don't care much in which type of storage it is at, but it should be super fast and start basically answering the user requests as fast as possible. So for me, it's more on the application level, but it's still some sort of data that needs to flow into the instances that we are spinning on.
And that's very similar for you, I think, Abhi, yeah?
Yeah, I mean, so trying to answer this from the lens of AI workloads, first I'll answer what data means. So in AI inference workload case, data is not just training data. So it is model weights, it is KV cache, prefixes, LoRa adapters, and all those great, nice things that help you service your inference request. Everybody wants their chat application to go as fast as possible. So latency is the king. So when I tie to data locality now, the question that is asked around data locality for inference workload typically means sending the request to the right machine that has all these different layers of warmed up data, which can satisfy your SLO.
And all of this is very easy, right? Totally simple, done, like solutions exist that like you can just plug and play, no problem.
Yeah, they exist in 2050.
2050, brilliant. So what are some of the gaps that you're fighting right now?
It's a totally different paradigm, right? So let me explain the paradigm. This may not be an exact example, but here's a coarse example, right? So think about this browser that we have, right? Everybody is using browser now in this forum, and usually browser is the one that manages state for us. So what is state inside the browser? One of the state inside the browser is cookies, right? And these cookies are 1 megabyte, 1 kilobyte, or few bytes, right? In a cloud native context, maybe this is a very strong opinion, but nobody really thinks about state. We are all in for stateless, but less for state. I'm trying to answer this question from an AI inference workload perspective. So when you move to AI inference workload, state becomes suddenly the king. So what is this state now? All the artifacts that you keep inside your GPU to create the next token for your inference really becomes important. And this state is not megabytes or kilobytes, but it is hundreds of gigabytes to even terabytes that is sharded across the nodes. So this is a very complex question, but due to this size, there are issues with data transfer across the node. There are issues with load balancing. There are issues with request routing. So maybe that ties into scheduling. There are issues with auto scaling. So yeah, generally these are the issues: scheduling, auto scaling, load balancing, request routing.
Just a few things, just a few. It's interesting you have your analogy was with a browser, just because I'm still annoyed that I can't get the same tabs open on all my devices. Why is that, or why is that so hard? But so Abhi's problems are probably pretty similar to yours, right?
Yes, exactly. So I relate a lot here. So for me, for our team especially, the problems are also moving those huge models. They got out of control, people. It's like hundreds of gigabytes, sometimes terabytes. We divide them into multiple nodes, and moving those from a storage to a GPU is taking a lot of time with traditional loading mechanisms and tools. So that's one thing that's super tough right now. The second thing is a bit on the training side. So when you split those models on multiple nodes, they will communicate with each other, like those shards. And it matters a lot how you schedule those pieces, those pods in the network, so that the network bandwidth is leveraged properly. And you need to have a specific scheduler for that, which is super important. And depending on the parallelism techniques that you are using for your models, that also matters, that also differs a lot. So that's another thing. And auto-scaling is another piece, because you need to auto-scale these models in AI inference while paying attention to all these SLOs, all these network overheads, and all these data, these tensors that you need to move through different nodes to another one. So yeah, it's a lot of movement that's happening, both in training side and inference side within the application layer. All these components need to move together, act together, which is quite challenging.
Yours is a slightly different level, yeah?
Yeah, I'm a step before that even, because you want to run your jobs, but they first need to be scheduled somewhere. So that's the first decision that the Kubernetes scheduler needs to make. It gets that pod, it needs to place it somewhere. If it knows anything about data or data locality, it can take that into account. But at this point in time, it's just not there. We don't know where the data is. We know maybe a volume, but we've got no idea where that volume is. If it is, even if we know where the volume is, do we know if the data stored within that volume is an object store? It could be 10 different physical instances underneath it with 10 different stores underneath. So you don't know that from a scheduling perspective. So we've got a problem before that even. Network configurations. The scheduler has got no idea about the network configurations in the current Kubernetes layout. We don't even know if it is a 1 gigabyte or a 10 gigabyte network connection coming into the node. That detail, that's not part of the scheduling steps. So we've got an even bigger problem even before we get to their problem to place the things together in the right configuration.
Yeah, I tend to agree with you. Like, I'm still just trying to figure out your level of things, the macro of like, is this piece of data in this data center? I don't know. So
You don't know.
Yeah.
You don't know from a scaling perspective because we don't even know what data is being used.
And I'll just point out here, Wilfred is kindly has stepped up and taken the place of Alon, who was going to be here. Alon, CTO of Vast. I was really interested to see from the storage side of things how they think of data locality and how they would talk about we're trying to get you the unified understanding of where your piece of data is. I think they're trying to approach it from their point of view. Unfortunately, the planes would not deliver Alon here in time, so Wilfred has stepped in. Dan, how does this compare to your non-Kubernetes world and the problems that you're facing?
What we're experimenting right now is flipping, I guess, the order of importance. So we've made the scheduler take a back seat, and the workers it's a worker-centric distributed computing sort of framework idea. They show up and they pull work. And the scheduler has to make a decision at that time based on the workers it's recently seen and their capabilities, and based on active jobs that it has, to make a nice little package, of pieces of the different jobs and give it to those workers. And the idea is to release these prepackaged pieces of jobs in a way that maximizes throughput, minimizes costs, all that good stuff. But that's how we sort of sidestep the node discoverability problem. Is we have the nodes themselves self-report, show up and ask for work, but it adds the other problem of now we have to kind of keep track loosely of the most recently seeing nodes, what they're capable of, and giving them work. There's an analogy. Abby and I were having coffee and we were saying, you know what, I view this as a bit of like a post office. A lot of people are sending a lot of mail to the post office. And you have these different sized delivery trucks that are sort of showing up, and you don't know exactly when they're going to show up, but they're supposed to show up. And in our little post office, we're trying to have people sort of pre-package, bundles of envelopes and boxes of the right size, in hopes that the right truck shows up, and then over time it's doing that somewhat efficiently.
But you're to some degree, like us, kind of flying blind. Like, you don't know exactly where that node is. It reported for work, but you don't know what network it's on, or how fast that network is, or you don't know much about it beyond how much CPU it says it has to offer, right?
Beyond what it reports, but it, the more we instrument them, it could give you a bit of a snapshot of what its current bandwidth is, other things. And so we're relying on like meta statistics to try and do somewhat of a good job to parcel out the work.
So we're sort of hitting on the problems here. And so we've sort of caught everybody in the room back up to what it is we're talking about and the problems therein. The one that Wilfred brings up is one that is near and dear to my heart, just like we all have built schedulers at some level, at some point in our lives. And right now in Kubernetes land, there's lots and lots of questions that are yet, that are problems. Like, the scheduler would be able to schedule things much more intelligently if it had all of this extra information that we really don't have. Topology, awareness, like all sorts of pieces that Kubernetes doesn't natively provide to you out of the box, sort of on purpose. So with that, all right, the 15, 20 minutes worth of background to the topic, what is it that is happening or that you're doing today to try and improve the situation? I'll start with you, Avi.
Okay, so here's my chance to do a little bit of shameless marketing. So as I mentioned, I'm trying to build an open source platform. So I work with the LLMD community. LLMD stands for LLM in a distributed fashion. If we go back to the previous question, there were challenges around scheduling, request scaling or request sending, auto scaling. So these are the fundamental building blocks, as we all know, of Kubernetes, right? So what LLMD does is LLMD still leverages Kubernetes for pod-based scheduling, But if you want to route an inference request, satisfy SLO, optimize cost, then you would use this LLMD orchestrator on top of Kubernetes to try to get somewhere beyond the current default state of Kubernetes. So we have a lot of SIGs inside LLMD, and we welcome all of you to send your requirements and participate. And like I said, now I'll stop my shameless marketing pitch.
No, but it's all open source, you know.
Yes.
It's not so shameful. Ekin, you're just sort of doing some similar stuff, I think, in that.
Yes, another shame.
Well,
No,
yeah.
just joking. So yes, about the model loading part, we are working on another open source project that is maintained by our team and GKE team, actually. We started working together. It's called Run.ai Model Streamer, fully open source. Have a look. It is accelerating the model loading times from any type of storage to GPUs. So it's streaming the model weights. It's reading concurrently from any type of storage to while streaming them directly to GPU. We are also supporting object stores, which is not very common, especially in inference engines like VLLM or SGLang, if you are familiar with them. So super cool projects. We have some very interesting benchmarkings on cloud storage types, which are gonna get published soon, so stay tuned. So that's one thing that we are still pushing. Any ideas, feedback is very welcome, by the way. If you have anything, feel free to open a GitHub issue. And another thing that we are working on is on the topology side a bit. The Kai scheduler is now topology-aware scheduling. Of course, we have a lot to solve there, more to solve, but still it's the first piece, I would say. I recently ran benchmarkings with Model Streamer and Kai scheduler, divided one model and checked out how it performs with model parallelism using topology-aware scheduling. Very good. So we need topology-aware scheduling, that's for sure, for those big models. And for the auto-scaling part, today actually, we announced Grow being a part of Dynamo, which is a Kubernetes API, fully open source. All of these are open source. Feel free to have a look. It's making the disaggregated serving like on multi-node way more flexible in sense of auto-scaling and gang scheduling. So yeah, these are the small pieces that come on top of each other. I think it's going into the moving data direction to make the whole deal more efficient.
Cool. Wilfred?
Yeah, from the basic scheduling perspective, topology aware is the big problem at the moment that needs to be somehow fixed. We need to get some kind of topology information into Kubernetes, into the nodes, and then get that standardized. Because yeah, we can do node labeling. We can say Google Cloud might say, oh, we put all these labels on there. But if they use something completely different than AWS or the IBM Cloud or Alibaba, then from a Kubernetes scheduling perspective, it doesn't help, because then we need to get all these different implementations going. So looking at a topology-aware piece inside of Kubernetes itself, that's one step. Getting more information on where the data is. So a block store is nice. Local data on the node, yeah, that's good to know. But we need to know a little bit more than it's just a block store, or it's we need to have some costs that sits behind that. Transferring data, it's bandwidth. You say, oh, it's cheap, but if you're transferring gigabytes or terabytes, it all adds up. And the scheduler can make lots and lots and lots of decisions. It can help a lot putting things close together, but we need that information. So that's the big thing. The other thing that also pops up is gang scheduling. It doesn't help if I've got a training workload or an inference workload and only half of the pods run. It can't do anything. You need every single pod to run because they interact together. Data gets shared. So that's the other step. That's the other thing. There's a lot going on at those two levels at the moment in the open source Kubernetes versions. There's all kinds of caps open. But then again, and I've got a talk in a couple of days that goes into a couple of these things. There's differences in how people understand gang scheduling, data locality, all that kind of stuff. So up until we get to a shared understanding, it's not going to work because I can implement something that's gang scheduling, but that doesn't work maybe for inference workload, or it works perfectly for the inference workload, but it doesn't work for other batch kind of workloads, like what he's doing out with his stuff. So there's plenty of things still to work on.
I'm curious, Dan, whether you have thoughts on like what's progressing or what you're doing as well. Thank you for that. Yeah.
If there are any math modeling nerds in the room, like I definitely want to talk to you after, but we're taking that academic lens to see, okay, if we have this mixed bag of nodes that show up at the door and they can sort of self-report on some performance, so self-describe, and you have these jobs coming in from users post-estimation, so we do a little bit of micro-running of them before we release the hounds to characterize them. We're looking at it as a multi-dimensional knapsack problem that we want to optimize. And then optimize what? Right? Costs, performance, time, latency, fairness, these are all different issues when you have many people, using constrained resources. And there's significant literature on optimizing those problems. And so we're just going to take a crack at it. So if people think that the math approach would be interesting, like come talk, because whatever we end up doing with it, we're going to be sharing it with the community and everyone else. It's not a Kubernetes-based scheduler, but the math overhead of it, there should be some components that move scheduling. In general.
And to that point, like you and I and a bunch of us in the batch working group are working on an initiative to do some mathematical modeling of this sort of basic problem around data locality. Like, do you bring the data to the compute or the compute to the data? And trying to model that out in various millions of ways, which is another point to make clear to all of you. You're all here listening to us. You're clearly invested in this topic. There are conversations going on to try and address issues around all of this stuff. We're one part of that, the batch working group. We've got a couple of initiatives. The data locality conversation there is one of them. There's another conversation going on today around scheduling with Google that I could probably come up with a few more. I need my notes, but I don't have them. But there are actual conversations to come that are happening. So talk with us afterwards, and we'll try and connect you with those. One of the things that, maybe the last topic here, maybe for a quick one before we go to some questions, is I heard a bunch of you say topology is this big issue and that it doesn't really exist. In much the same way that like we have all built schedulers, terrible, terrible shame, but there's like Unicorn, there's Kai, you used to work on MCAD. We and a couple of other people here built Armada. All in response to the fact that the Kubernetes scheduler itself didn't do what we needed. And as much as I decry the fact that we have each gone and built another scheduler, it's really interesting also that every single scheduler is also going down the path of figuring out topology awareness. Like Volcano and Q themselves, they have conversations going on around this. So the question is, does this represent something a miss in the ecosystem, that if we're having to implement the exact same thing over and over in each scheduler that was yet a fix for the scheduler that didn't schedule our jobs. Is the community missing something? Should there be a unified conversation to try and fix something else in the ecosystem? Wilfred, what would you say?
Yes.
Good, lovely.
Yes. The whole topology awareness, it's been around for years. Like I said, I come from the HDFS time, and back then we had 10 megabit networks, and then we went up to 100 megabit networks, and we said data locality. Oh yeah, no, that's not going to be important soon, because then we get gigabit networks or even faster, and that's 15 years ago.
Yeah.
Data locality is still the exact same problem as it was 15 years ago. Our networks are about 100 times faster now, but our data has grown by that same factor. So it still is a problem. It's not going to go away. So yeah, we need to get to somewhere that gives us data locality in Kubernetes. That's we need to get that fixed.
I can see Ekin and Abhi sort of nodding along, but I wonder, I just saw the time, if there are any questions, I'd love to open it up. There's a question over there. Yeah.
First off, thank you for having this, because this is very much an active thing I am working on. So something I find interesting is that it sounds like a lot of you are looking at this from a perspective of rights. Has any work been done on the can of worms that is, or sorry, y'all are using this or thinking about this from a concept of reads. Has anyone been looking into the can of worms that is what happens when you write and need the data propagated everywhere? That's kind of where I'm stuck on this, because when the human is when a human being is the user of your data, and you have two people across the ocean working on a project together, it's very difficult to figure out, well, who's right. So if they both make a change, well, who has the most up-to-date copy? They both do. So I'm just curious on your thoughts on that, and if any work is being done to try and solve that.
Yeah, I mean, I can lay some thoughts around it, right? So, I mean, the way you frame the question, again, it falls into the category of representation, right? So, usually this writing and reading of data is more an AI training phase, right? And that goes through a collective communication channel. And usually this AI accelerators have their own proprietary network communication to begin with. And they will do a lot of maybe error checks under the hood, which is, at this point, I agree with you, it's black box. We as a community need to figure out, I'm very good at giving bad examples. So I'll give yet another bad example. We as a community for AI workload should figure out the next TCP that definitely works and does the error checking when multiple nodes are trying to write this data out. So that's still an open question. Some of the universities, I mean, are very important. And I believe University of Illinois or Chicago has been developing this protocol called UCL, UCCL, which stands for Unified Collective Communication Library, to look out it. And I mean, if you have more insights, please share feedback on that.
Yeah, very good question. Thank you.
And to add on top of that, it's not just the learning workloads, but also what happens if a node goes down and it's halfway through processing data. What do you do about checkpointing? Where are you? What's been done? How do you get your data? And how do you know what data has been written already, where you are? Checkpointing is not something that has been understood well. It's often left up to the application itself to do the checkpointing, and then hope that it all works out in the end. But when you start looking at moving things around on nodes because a node goes down, currently we just rerun the workloads 9 out of 10 times. It's easier, it's cheaper and easier than figuring out the checkpointing, which is weird. It should be the other way around. But yeah, we haven't figured that out yet. So
We might have time for one lightning one. We can run over here. Oh, sorry, I didn't see your hand.
there's
I saw this hand over
middle
here.
one, middle and
We have
back.
2 more.
Well, we got
Yeah,
1
probably we
minute.
can take 2 more.
Definitely gonna have coffee after.
I'll try to be quick.
Quick.
I'm an application developer, and so when I think of here data locality, I first think, oh shoot, are we going to the EU?
Yeah.
So I'm just wondering, do you have any thoughts on some of like GDPR? And like, I keep hearing people talk about almost the default data locality of running a second set of all your applications and third-party applications and whatever with those certificates and that say they're GDPR compliant. You know, the pros and cons of running a duplicate instance of your entire tech stack versus, say, getting some of those certificates to transfer the data to the US to do the processing if it's not sensitive. Do you have any thoughts on this?
I mean, I'd say our lens on this isn't to worry about GDPR or sovereignty, but that is one of the drivers that keeps potential compute away from where the data is, and that is one of the reasons for this complexity. So yeah, I don't think that any of us are worried about how to make sure that data sovereignty. Oh, you are? Yeah. Ooh, sorry, I stand correct.
No, I love that. In fact, that's my whole sales point. You know, when you can deploy these computing systems in a box in a hospital, you can constrain where that data lives and exists and computes, right? And respecting GDPR or HIPAA, or whatever other ones, you know, right out of the box. So I love that question, and yes, I agree.
Maybe talk to Dan afterwards. Yeah.
I just want to throw one complete spanner in the works. I know that one person who works at NVIDIA might also think of these similar problems, is that there are now kinds of systems that have transport layers between specific groups of nodes that are 100, 1,000 times faster than any storage server is ever going to give you access. So, like, it seems like there is a massive waste of resource in having storage. So the transport layer between the racks, every GPU in a GP200 is, depending on how you count it, 1,800 gigabytes per second. And that's way faster than S3 is going to let you download a file. So, and so wouldn't it make more sense to think of a way to like stream across those transport layers? Like you're actually targeting each network domain almost to like, only the first node in the rack needs to download. And I just have no idea how to tell, other than just telling Kubernetes to schedule a pod and all the pods figure out how to do that inside the pod. You know,
Yeah.
it's like, you know.
Well, I think this is the thing that we've been pointing to right at the end. That's maybe a nice place to end on, just sort of to reiterate that there is this large hole in this particular ecosystem of knowing how things are connected, how things are laid out. We're just sort of flying blind right now, and until we give Kubernetes or the schedulers we're talking about some way of looking in and seeing how everything is connected and what those fast paths might be, it's going to not be as optimal as it's going to still be slow.
Yeah,
So-
but I won't just would.
Go.
I mean, I would just like to give a pointer to you. So there is this project by upstream inside Kubernetes called DRA. In DRA, there is this feature called consumable capacity. And I think some of the issues that you are facing could be addressed by consumable capacity. They are not solved, but I would like you to go and read the consumable capacity cap and throw some requirements there.
Perfect. With that, thank you for the questions. Appreciate it. We'll be around to chat about this stuff. Thank you.
Thank you.